Uh, Assalamualaikum and hi to everyone. My name is Muaz bin Baharuddin. In this video, I will present about my undergraduate project UGP2 with the title of Evaluation of Super Olein Oil on Different Materials. And let's go to the first chapter. As the project is concerned about the study of tribology, so tribology is the study of rubbing or the things that include contact between surfaces. The applications of tribology actually is widely used around us, where the application can be from simple to complex and the scales also can be from small to large. For example, gears and bearings, manufacturing process like turning and rolling, and automotive parts like engines. All of these applications include the fields of friction and wear. Take bearing as example. When the bearing is moving, it will produce friction, where friction will result to heat and wear. If one of these factors are not being considered, it will cause extreme damage and failure for the bearing. Thus, lubricants are needed as it is one of the conditions that can help to prevent damage on the product. The research on palm oil to replace the petroleum-based lubricants has increased because of the tribological properties that can help to improve its performance on different materials. Since the vegetable oils are renewable, biodegradable, and less toxicity towards environment, so it has the potential to act as an alternative lubricant, and it is also lead to my study to observe the tribological effect of vegetable oil under different materials. Here are the main objectives of study for my project. The first objective is to determine the coefficient of friction of super Olein oil for steel ball on aluminium, pure copper, and steel specimens. Secondly, to determine the wear resistance of super Olein on different materials. And lastly, to compare the coefficient of friction of super Olein oil with commercial mineral engine oil. However, these are the scopes and limitation of works for my project, in which the test parameters that need to be taken into consideration are: the temperature must be fixed at room temperature, motion is in a linear motion, frequency must fix at 2 Hz, and load also fixed at 25 Newton, and the engine oil will be used as a benchmarking oil. Now, here are the findings that I have been reviewed, where the authors want to investigate the performance of refined, bleached, and deodorized palm oil by using a pin on this tester. They observed that the RBD showed better anti-frictional and anti-wear performance when compared to hydraulic mineral oil. The coefficient of friction increased as the sliding speed increased for both lubricants, and this is because the unsaturated fatty acid played an important role to reduce the coefficient of friction and wear. A study conducted by Shahrulail, Nuraliza, Izhan Hamid and Razaka, which they want to study the influence of the normal load on friction and wear performance, were investigated for a RBD palm oil and compared with paraffinic mineral oil using 4-ball tribo tester. They observed that the RBD palm oil showed a lower coefficient of friction compared to the paraffinic mineral oil under all tests at various normal loads, but it creates larger wear scar compared to paraffinic mineral oil. Various trends of results have been shown from previous studies with different operating conditions like loads and velocity, but there is no relationship is found for friction at different materials. And here is the finding that be found by using different material pairs to study the performance of coefficient of friction on the materials without any lubricants. The researchers observed that as load increased, the coefficient of friction decreased while increasing speed, will also increase the coefficient of friction. The coefficient of friction for sliding pairs are different, where soft-hard contact will give higher coefficient of friction compared to hard-soft contact. Okay, this is my work planning. Okay, here are my Gantt chart for this project. All the experiments was conducted and the results was analyzed from week 7th to 14th. And the writing thesis and literature review also was done from first week until week 15th. This is my flowchart on the project. All the background study, literature review, experiments, and data analyzing processes are included in order to complete the project. After that, I will be explain about the methodology that required for my project. For the preparation, these are the materials and lubricants that used in order to conduct the experiment. The lubricants that selected are superolin and commercial mineral engine oil. Next, the hardness test was conducted in order to identify the hardness of the materials of aluminium, pure copper, and SKD11. Since the materials are small in dimension with 20 mm x 20 mm x 10 mm, the Vickers hardness machine was used as it is suitable for small parts, thin sections, or case depth work. The test is performed followed on ASTM standard E384. It has been tested that SKD11 are the hardest compared to copper and aluminium. After that, the linear reciprocating testing was conducted in order to determine the results of coefficient friction of superolin on different materials. The conditions that being used for this experiment was based on ASTM standard G13305, which is the standard test method for linearly reciprocating ball on flat sliding wheel. All the test methods regarding for wear testing and guidance for measuring and reporting friction coefficients are based on the ASTM standards. The test was run under of these conditions. Now we are explaining about the result of coefficient of friction. Both lubricants has the same trend, which coefficient of both lubricants is higher when having contact on copper compared to SKD11 and aluminium. The coefficient of friction of superolin is lower compared to commercial mineral engine oil, even with the lower load and sliding speed applied. This is due to the long fatty acid molecules that firmly attach to the contacted surface has reduced the force that carried by the asperities. The long fatty acid chain has the ability to show intense and strong intermolecular reactions between fatty acid and metal surface molecules. This reaction will allow the fatty acid molecules to penetrate the metal surface, thus minimizing contact asperity and giving a lower coefficient of friction. Next, for the mean wear scar diameter, the trend is similar for both lubricants, where the wear scar of superolin is higher when having contact with aluminium compared to copper and SKD11. However, due to the hardness of the material, the wear scar of ball under superolin on aluminium is higher compared to copper and SKD11. But it is differently on copper, where the wear scar of superolin is higher, which is slightly similar to wear scar of superolin on aluminium. Even with the lower load and sliding speed applied, the wear scar of superolin is higher. This is because of the chemical attack on the rubbing surfaces by the fatty acid in the superolin. The unsaturated double bond of fatty acid molecules was exposed to the chemical reaction, which causes brittleness and weakens the metal surface. Thus, it will increase the wear and widen the wear scar. Okay, this is wear worn characteristic. The wear scars were well formed in both lubricants for steel ball and specimens. The wear scar on the steel ball for both lubricants were in horizontal, and circular shape since the machine was operating in linear condition with stroke or sliding distance of 10 mm. It can be seen that the like parallel scratches were formed where the scratches of steel ball between the aluminium are well formed compared to copper and SKD11. The like parallel scratches that found are classified as abrasive wear, where it was also found that a lot of shear surface at the middle of the scar, and which at the edge of the scar are due to the adhesive and abrasive wear of brittle material. For the volume loss, the trend is decreasing according to the hardness of materials for both lubricants. The volume loss of superolin on copper is higher compared to the commercial mineral engine oil, and it can be seen that when wear increase, the coefficient of friction will decrease, and this also will affect the volume loss of the ball, and this may be related to the increase of shear strength of the ball and affects the chemical attack on surface of fatty acid exists in palm oil. So here are the summarization of progress for my objective. All the objectives have been done where the coefficient of friction of superolin and wear resistance have been determined on different materials, and the comparison of coefficient of friction for superolin and commercial mineral engine oil has been compared. And to conclude, the coefficient of friction values for superolin is lower compared to commercial mineral engine oil on different materials. The wear diameter of steel ball for superolin oil is higher on different materials compared to commercial mineral engine oil, and the wear worn on aluminum plate can be seen clearly compared to copper and SKD11 specimens. The adhesive and abrasive wear was observed on steel ball and materials. And lastly, the hardness of materials on friction and wear mechanisms has been observed that SKD11 is harder compared to copper and aluminium. Lastly, for the recommendations that can be suggested for the future works include of the parameters like load, temperature and sliding speed should be added with various values so that the effect of wear and friction characteristic can be analyzed well. The superolin oil also can be improved its performance by adding some additive that can interface its weaknesses. The surface roughness of materials should be taken in order to obtain the clear results on the microstructure of materials after the tribological process. And the superolin oil also can be mixed with mineral-based lubricants to obtain the optimum coefficient of friction. That's all for my presentation, and thank you.